This time we're going to look at using a spreadsheet program to help you manipulate data that you may have generated in the lab by using statistics. This is statistics light, but it's going to be very useful for early college work. I'm going to give you some useful hints on how you might use, in this case, the OpenOffice Calc program to find outlier data that you can disregard in your analysis, and how to generate a usable plus or minus number for your average. And we're going to use data that was generated and then I've massaged a bit. It's actually student data that I've worked with, so that you can see the principles on how this is done. You can do the same thing with the Google Spreadsheet program, with Excel, or with Quattro Pro. Here's some data that I've typed into a spreadsheet program. And let me show you how you might be able to work with this data. This is data that was generated by AP students, and then I've massaged a little bit. And this is a set of data that's kind of a before and after. Over here we have a column of sodium hydrogen carbonate masses. Then they added hydrochloric acid to convert it completely to sodium chloride, and that mass you have in this column. So let's first of all look up here and see that the NaHCO3, we really would like to have the 3 as a subscript. So what we can do is we can highlight that and right-click and click on Character, and then we can choose Subscript. There are other ways to do that, particularly in programs like Excel. And I'm going to do that over here as well. Change that to a subscript. The next thing we would like to do is convert all of the masses to millimoles, because obviously we have to work in the mole hole in order to get anything done. So we're going to go here and we're going to say, this is the way we do formulas in spreadsheet programs. We're going to type equals, and then we're going to go over here and grab A2, which in this case has 1.87 in it, and we are going to divide that by 84, which is the molar mass of sodium hydrogen carbonate. And this will give us moles, but we want millimoles. So we know there's 1,000 millimoles in a mole, so we're going to then multiply, that's the asterisk, by 1,000. And we get a number which has way too many significant digits. So what we'd like to do is change this so that we have only one decimal after. We want 3 significant digits. So we'll have 1 digit after the decimal point. So we put our number here, and we right-click, change to format, and when we want to format it as a number, as it says here, and we want 1 decimal place after the decimal point, 1 digit after the decimal point. We click on OK, and that's a much easier thing to work with. Now we're going to do the same thing with the sodium chloride, and we say equals, we grab this sodium chloride mass, and we come back over here and we're going to divide this time by 58.44, which is the molar mass. I'm going to go ahead and put parentheses around this and multiply that also by 1,000. And we'll again format this, right-click, format cells, 1 decimal place, OK. Now the beautiful thing about a spreadsheet program, and you're maybe working with as many as 40 or 50 or even 100 or more data sets, is now we can go ahead and select these 2 formulas. We're going to copy it. I'm going to use the Control Copy on the keyboard, and then we're going to go all the way down here. We're going to paint out that area, and I'm going to say Shift Insert, and as you can see, I now have that formula propagated all the way down these columns. So we have converted to millimoles with almost no trouble. Okay, just for fun, I'm going to go ahead now and do a little formatting here. We're going to put all of these numbers and letters right in the middle of the column, and we do that up here, aligned center horizontally. Now what we want here is the molar ratio in this reaction. And so here we're going to type in a new column, and we'll just call it ratio. This is the ratio of sodium chloride to sodium hydrogen carbonate. And down here we push equals, and then I'm going to just open a parenthesis. I'm going to go over here and grab the millimoles of sodium chloride, and I'm going to divide by the millimoles of sodium hydrogen carbonate. Close parens, and I get a ratio of 1.2. Now we format that as we did before. In this case, we want 2 significant digits after the decimal point so that we have a total of 3. And see, it rounds it off to 1.21. We come up here, press Control C, and we propagate all the way down by pushing Shift Insert. And as you can see, some of these numbers are very close to 1, and others are not. These we suspect to being outliers. And we can test those for outlier by finding the range. Now, in order to find a range, we've got to order these things from least to greatest. So I'm going to I'm going to select all the way across the page here, because it's going to rearrange all of these lines. I'm going to come up here, and I'm going to go to Data and Sort. All spreadsheet programs allow you to do this. I'm going to sort by column E. As you can see, that's the ratio we want to sort by. And I'm going to sort ascending. And if I click on OK, I have the smallest at the top and the largest at the bottom. And now I can easily go over here and calculate the range. And I'll put that, let's go ahead and resize this box of titles. I'm going to put the range over here, and we're just going to say equals this minus that. And I'm not so worried about that. So the range is 0.886. Now let's just suppose, and let's just go ahead and move this up here. Now we're going to do the gap. And the gap here, of course, is the difference between this, not in that, because that we suspect for being an outlier. We're going to choose one that we know is in the 1.0 range of the 0.84. So we're going to say equals this minus that. Okay, that's the gap. I'm going to put it over here. And I'm going to call it gap. And then I'm going to calculate Q. And Q, of course, is equal to this divided by that. And it's 0.589. Now I've just got 8 data points here. But I look up in a table and I see whether I can get rid of this or not. I look up in a Q maximum table to see if I can get rid of that or not. So let's suppose that we find out that these two, 0.32 and 0.43, fail the test, fail the Q test, and we would like to get them out of our data. We don't want to completely eliminate them. We don't ever like to lose data. So what we're going to do is paint this out and push Control X to cut. Then we're going to come down here and we're going to start an outlier table. So I type that there, and now I'm going to bring back those 2 rows by pressing Control V or Insert or whatever it is that you'd like to do. Shift Insert does the same thing. So we haven't lost our data, but again, we're not going to use it up here. Okay, we're now going to work on this table. We want the average. So that's what we're going to report as our ratio in our lab report. The average is going to be placed over here. So we're going to type equals. Now, each spreadsheet program does this a little differently. But one thing they do is they give us hints. So let's start average. That's what we want. Average. We open parens. It tells us to do that. And then we're going to paint this out. As you can see, it goes E4 to E9. Close parens. And there's our average, which we're going to format. And let's get 2 significant digits here after the decimal point. Two digits after the decimal point. 0.98, which is very respectably close to 1. Now we go down here and we can do the average deviation or the standard deviation. Let's do the standard deviation. Okay, we go over here and equals, open parens, STDEV. We open parens inside again, and we again paint this out to see what the standard deviation is. It's going to be pretty big because there's a pretty big range there. 0.198, we are again, in this case we're just going to have 2 significant digits after the decimal point. So we format, decimal places, OK. So we're going to report 0.98 plus or minus 0.20. And if we want to be very, very sure of our data, we would report, we would use this also as an outlier test. And if we use this as an outlier test, it's plus or minus 0.40 because we have to double our standard deviation. So this is not very precise, although when we consider that this stoichiometry says that the ratio should be 1.0, it is quite accurate. So we can then report our ratio in this particular set of data as 0.98 plus or minus 0.20, and that's what we would put on our lab report.